This conference will now be recorded.
So don't say anything you might regret. Thanks everybody for joining us during such a busy month. It's I don't know where May went, and I kind of know some of the things. It just seemed to flash by, and we had quite a few people who wanted to join us who had graduations and exams and end of year things, end of school year activities, and then a lot of grants are due at this time. I had a grant due last Friday, which took an entire week to pull together. And then I don't know, it just seems like there's always a lot going on in May. But so I'm thankful to everybody who had time to sit in with us and learn more about what people are doing in 3D printing, and to encourage more women to participate. What we normally do is we just go around, someday the room, but now the screen, and people just kind of introduce who they are and where they're from. Nothing long, no description really, but name, organization, and maybe a sentence about who you are and what you do. And so I can start. And it's Sarah Boisvert, and I'm the founder and CEO of FabLab Hub, part of the MIT FabLab Network and the New Color Network, that is a nonprofit. Indy, you want to go next?
My name is India Byrne. I'm currently unemployed at the moment, but my specialty is an IT professional, and I'm currently in my semester for that. We're getting my 4 industry standard certifications this year.
And we can see a 3D printer behind you.
I have 2.
Very cool. Emily?
Hi, I'm Emily. I'm from the New Mexico Tech Council. I heard great things about the meeting last month, and I wanted to come and hear it myself. Thanks for having me.
And what do you do at the Tech Council?
Aha! I am the marketing and manager.
Cool. And Bill, thank you for joining us.
Yeah, my name is Bill Baker. I'm retired from Texas Instruments and living in Santa Fe. And I met Sarah a couple of weeks ago, and we had a nice, almost 2-hour chat. And basically, I'm involved in a conference here, and we're going to be featuring disruptive technologies. And that includes 3D printing. So I'm here to learn.
Cool, Bill. And Bill has a lot of experience. We belong to the Association for Manufacturing Excellence, which is associated with SME, the Society of Manufacturing Engineers. And Bill and his group roped me into helping them in their 2022 conference in Dallas, that I think will be a lot of fun. Yeah.
We hope so too, Sarah. Now we're shooting for 2,000 people, so that's what we were before COVID.
Yeah, it'll be, and we'll feature lots of technologies, but 3D printing obviously will be a big area. And Jed, you want to go next?
I'm Jedediah Beto, and I'm from New Mexico. I'm up here in Los Alamos, and I work for Sarah at her Fab Lab in Santa Fe.
Did you not invite the pretend Jed?
Oh, when I was taking classes with Hank, the guy we used to work with, I had to keep rejoining, and it would leave like a me, like a just an empty screen. Like some of these people have a circle with their name, but like it's just an empty me, and so I just put it as the real Jed. I don't know. I forgot to change it.
That's great. And Alex?
Yeah, I'm Alec, and I work alongside Jed as a 3D printing apprentice, working for the Fab Lab Hub.
Great. Mary?
Thanks, Sarah. I'm Mary Tiemann. I'm with the New Mexico Technology Council. I'm the Community Relations and Membership Development Director.
Cool. And Susan, are you in Denver?
Yep, in Loveland, about an hour north. But I'm based in Albuquerque with Westwind, and we have 3D printers and also a additive manufacturing center there.
Great. And MK?
Yes, I am the media manager. Can everybody hear me all right?
Yep.
Good. Okay. Just want to make sure my mic was happening today. Media manager at the New Color Network and the Fab Lab Hub LLC, and just thrilled to be here and be a part of this community.
Thanks, MK. And Jacqueline?
Hi, everyone. Thank you, Sarah, for having me. I am located down in La Luz, so kind of the southern part of the state. I'm the president of the Land of Enchantment chapter of Women in Aviation International. So my field is aviation. I'm a military pilot. I actually just got off active duty this summer, switched to the reserves. So I still fly for the Marine Corps. I'm also a rancher, and I'm working on a master's degree in public leadership.
Oh, awesome.
A lot of things. Brandon?
Hi, I work with Susan at Westwind. I'm also a design engineer for Roadrunner 3D, which is an additive manufacturing service bureau in Albuquerque, New Mexico.
And Brandon a little later is going to talk about rapid prototyping for us. Hi, Jill.
Hello, everyone. I am Jill. I work in the beauty industry, actually. I feel like a little bit of an intruder. I'm outside of New Mexico. I'm in Los Angeles. I learned about your group through Sophia Mitchell, who's further on down in the Hollywood squares.
I'll remember them. Andrea.
I'm Andrea Weichel. I work at HP Inc. I'm in 3D sales, and I am a partner business manager for Mexico and Brazil, and a territory rep for California and Nevada, based in Rio Rancho, New Mexico.
Beautiful place. Sophia? You're muted.
I do this all the time. So my name is Sophia Mitchell, and my colleague, as Jill Manning, is down in Los Angeles. I'm up here in the San Francisco area. I'm a cosmetic chemist, and we are on a journey through the NSF to build a 3D printer for printing a point-of-care skincare products.
Cool.
That's cool. Very cool. And last but not least, Deborah.
Hi, everyone. I'm Deborah Breitfeld, and I'm in the middle of kind of the perfect Zoom storm. My teenagers kicked me out of my office at the kitchen table, and so I apologize. I'm kind of in the dark, and the neighbor's dog is barking, and my cat's meowing outside the door. But I'm really excited to be here. I should have just stayed at Fat Pipe. I'm the executive director of the New Mexico Technology Council.
Oh, I can't even hear the dog.
I can't either.
Well, this is
what dog?
And I'm happy that we have some men who join us and support our group. Last time I had too much on my mind and I skipped over Mary, who wanted to talk for a minute about the New Mexico Tech Council, who are our co-host with the New Color Network of this chapter of Women in 3D Printing, this international chapter. And Mary, do you want to talk for a minute about the awards?
Oh, yes, sure. Thank you very much, Sarah. I appreciate that. So I wanted to share with everyone, I thought this was the perfect group to share. We have an event coming up June 10th. It is our Women in Technology Award celebration. It will be virtual, but, and so with that said, because you're in LA and San Francisco, you can still join our amazing event. I'll put the link to register for this event in the chat if that's okay, Sarah. But we have an amazing speaker, JJ DiGeronimo. She's internationally known, and I think she's going to bring, you know, a great speaking for the event. And so with that, I thought this was the perfect group, Women in 3D, and so we hope you will join our event on June 10th. Thank you, Sarah.
Oh, you're welcome. And I was fortunate enough last year to get one of the wonderful awards. And the best part was the Nambe tray. That, you know, so often you get these lovely but not practical plaques and things. And when you're old, you've done it a long time and you have such a supply of plaques and, you know, statues. And I used my Nambe tray on my desk, and it's just one of the most wonderful awards presents I've really ever gotten. So I wanted to give you that feedback that it's I see it every day.
Well, 6 amazing women will get their Nambe Award this year, including one emerging leader, and we'll also be giving away, sponsored by Nusenda, we'll be giving away a $5,000 scholarship for continuing education in the technology field. So it's going to be an awesome event. All of you will want to be there.
Cool. And if you just put the link in the chat, that would be great.
Sure,
I would
do that right now.
A minute before we go to our Ignite talks. So as many of you know, Fab Lab Hub and the New Color Network are recognized organizations in the MIT Fab Lab Network. So we have 2,000 digital fabrication laboratories around the world. They're all different. Some of them are associated with colleges or K-12 or museums. They're typically not standalone like a makerspace. They're typically associated with an institution, so they tend to have a little more purpose of the organization. And they are also associated with MIT and with the Center for Bits and Atoms and Neil Gershenfeld, who founded the network. And so every year we gather someplace, and this year was supposed to be Montreal, but it turns out that the Canadians, for reasons that are not clear to me, because I always think of them as being like just like us, because we're North America, are not doing so well with COVID, and we fear that it's not going to be reopened. And what we're going to do is, as we did last year was 100% virtual, but we're going to try to have some distributed events throughout the country. And the New Color Network has I think 12 or 14 organizations that participate. Fab Lab El Paso, Fab Lab Tulsa, the Community College of Baltimore County, Lorain County Community College in Ohio, which is an absolutely amazing place in manufacturing of all kinds. And we're probably going to do a kind of a Mountain States Western hub distributed event here in Santa Fe. And would like to see us have something happening with maybe workshops. Usually our workshops are, although they can be anything since this is a whole new world, they're usually a couple hours, and they can range from something theoretical to something very hands-on. And then we often have a lot of challenges. I'm trying to get one of our sponsors who's in Phoenix, who builds CNC machines, to sponsor a challenge. And it's going to coincide with the grand opening that got delayed a year of our lab at the Higher Education Center in Santa Fe. So it is the week of August 8th, and I'll probably reach out to people in advance to get some ideas on what you might like to do for workshops. It's highly educational, and the people in our network are pretty amazing. It's a privilege to be associated with this group, and so I'm really excited in some ways to not be going to Montreal and instead to regionally being able to host something in the Southwest. So I will send you more details on that, and would love to see, a real event. It's not just 3D printing, it's digital fabrication. So it's everything from wearables. Last year, our challenge obviously was something for COVID, and one of the entries was a dress that had spikes, and you wore your dress, and if somebody got within 6 feet of you, sensors determined spikes came out and created all around you a little tutu of protection.
That's funny.
Very creative.
It's so creative.
I really want one of those.
So creative. My favorite of all of the, so this course is taught at MIT by Neil Gershenfeld, and my favorite one of his students' class projects from years ago is a student who had a really hard time, and she was a poli-sci major, I think. People take these classes who are in every field you can imagine, not just 3D printing or not just laser, not just digital fabrication. And she had a hard time getting out of bed in the morning, but she didn't like to be cold. So she created an alarm that had a connection to a pulley that pulled her covers off of her, and that forced her to get out of bed in order to it's now cold. And that's my favorite one. I think that's just so cool. But it is an amazingly creative and innovative and just amazing group to be a part of, and we're really lucky to have that collaboration. So I'll send more stuff, but if you have ideas or want to reach out and say I have an idea for a challenge or something we want to do, we're open to every idea you could imagine. So MK, who is our media director, MK lives in a gorgeous place north of us in Santa Fe that has really bad internet, as much of New Mexico does. So you can't see her, but MK was really kind enough to help us with lining up our speakers, because I was doing my NSF grant proposal, and our first speaker is Jacqueline Nichols, who comes to us from the Land of Enchantment chapter of Women in Aviation. And she's going to talk. So our Ignite talks are 5 minutes, and I time them because I am an old school conference person. And so it's just a few words about kind of what's happening in aviation and 3D printing. And Jacqueline, I'll let you take it away. Did you want to have slides or not? It doesn't matter.
No, if it's okay, I'll just tell a story.
That's fine.
Okay, so again, my name's Jacqueline. I live down in La Luz, and I'm a pilot, fly for the Marine Corps. And I currently fly a twin-engine jet, but I used to fly a CH-53 Echo, which is the largest helicopter in the military. And I'll tell you why 3D printing is so important that the military is starting to invest in it. We need to be able to make parts. We need to be able to make them immediately. For the 53 Echo, it's being phased out. So the 53 kilo is what's going to replace it. And in that phase out process, they're not making that many parts for the Echo anymore. So when I was still flying the 53 Echo, I had been testing that aircraft. Whenever they have maintenance, we have to test fly them before people can get back on them. And so I was doing the test flight. Well, I wasn't able to finish because we can only do it during daylight and the sun was setting. So the next day, another crew picked up the testing on this helicopter. Well, it was one of my really good buddies. And so we went through flight school together. And whenever we test, it was down in San Diego. We go over the Pacific Ocean in case anything goes wrong. At least we minimize the damage. So while they were testing, all of a sudden, all of their gauges, started to go down. And what they realized is they had a main gearbox oil leak. And I don't mean just a little leak, like it was completely dumping out. And the crew chiefs in the back were letting them know. And we have a book called the NATOPS that tells us, what we can do in case of emergency. It's everything we need to know about our plane. And per the NATOPS, you have 30 minutes from that happening to your rotor blade seizing, because that main gearbox will seize. So in this particular case, they didn't want to wait 30 minutes to see what would happen. So they literally just turned for the coast and flew a straight line to get there as fast as they could. And they were able to land the helicopter on the beach safely. Well, when they did, they landed in Del Mar Beach, and there were beachgoers, and they tried to land safely as they could away from people, but still sandblast while everybody got out their cell phones and were recording it. But once they got the aircraft landed, they realized that the part that had failed, we didn't have any in the supply system. We didn't have any in the squadron. There were none in the supply system. And so it was a race against the clock because the tide was going to come in and the helicopter was going to get stuck. They had to fabricate this part from scratch. And so between our airframes department and the logistics squadron, at the higher level, they were just racing to try to fabricate this part. And they were able to get it patched enough that they were able to take off, land at the Del Mar Fairgrounds, and be able to at least get it out of the sand. But it took, I think, about a week to get that part appropriately fabricated. And so that's why 3D printing is going to be so revolutionary for the military, is to get those really important parts made, being able to make them in combat zones, being able to make them on ships, and not have to worry about the supply system, because honestly, that's one of our biggest hangups in the military is relying on the supply system. It can get very backed up. So it's, I think they're in the process of getting more of them. Of course, there's a lot of relationships with these big aerospace companies that it's challenging because they're going to lose money in the process. So there's a lot of, congressional hiccups with that. But like I said, it's going to be a game changer once the military can go full forward with getting 3D printers for aviation. Was that 5 minutes, Sarah? Oh, you're muted.
That was a great example.
Yeah, it is a great example. And it's, I was going to say that actually my group at MIT, so as many of you know, the Media Lab is funded, we're in the Media Lab, is funded by huge contracts. And we had a giant contract with DARPA on exactly that, on supply chain. And we can't really talk about it, but it ended about 5 years ago, actually. And then we had a contract with the Naval Yard in Norfolk to put 3D printing on ships. We do a project with the UN to put 3D printers in war zones field hospitals, refugee camps, and exactly for what you're talking about, where you can't get a part. And for obsolete parts, a great example is Jay Leno, who has a number of, and I think a few times back, I gave a presentation on when do you use 3D printing, and that's a great example, is when you're reverse engineering a part that is obsolete. And I have this picture of Jay Leno telling Tom Brokaw about his 3D printer and how he uses it to make the parts that are obsolete in his car collection, in his antique car collection. And so those are all really, really interesting applications. The big defense contractors are leading the way in metal 3D printing. GE Additive has one of the most robust programs that feeds directly into GE Aviation. Boeing has a huge program. The problem in aviation is getting the parts certified. And how do you ensure that a part that is manufactured in 3D printing is also equal to a part that is manufactured traditionally? And Boeing has put tons of money into universities to research the part certification. Airbus has told us, because my group at MIT has a contract with Airbus, Airbus has told us they save 55% in weight on parts that are 3D printed versus traditional subtractive manufacturing, and that's because they can use complex geometries. And when you move to complex geometries from a solid part, you can really change the characteristics of it, but still maintain weight. The GE LEAP engine is the poster child of 3D printing, and after a while you get sick of hearing about the LEAP engine. There's a valve in the LEAP engine that has been 3D printed by GE, God, for, I don't know, 10 years. It's made of titanium. It has it used to have 20 parts, and with 3D printing, because, and I think Brandon's probably going to talk about in rapid prototyping how you can create parts that are fully assembled, and so, or at least partially assembled, and reduce your parts count. And the advantage of that in aviation is that then you have less welds. And so if you are reducing the number of welds, you're increasing your part strength. And so they're increasing part strength by about 40%, because they were going from 20 parts on this valve to 4 or 5 parts. So you have reduced weight, you have reduced parts count, you have increased strength. The downside, which they all don't talk about, is yield. And so the GE machine is a $3 million printer. It prints metal, and their yield, the last I heard, was up to 40%. When they started, their yield was 20%. Most companies could not stay in business with a yield of 40%. I need to be up around 80–90% to make money, and preferably like 95% to make money. And when you've got yields down at 20%, not just the cost of the material that you're throwing away, but the time, the energy, so many factors that come into the cost of that. GE's working really hard to increase that yield, but it's not for the faint of heart, and that's why the big aerospace companies like SpaceX and GE and Boeing are all in that space, because they have the money to do it. And some little startup just doesn't have the resources. So it's a really exciting space. Aerospace is a lot of fun, and SpaceX. My company in Maryland that I sold those parts for SpaceX, and there's a lot of 3D printing going into the SpaceX machines. And then on the space station, they are 3D printing in space, but it's still controlled from the ground. It's controlled remotely. But that's such a great application, Jacqueline, and it tells you where 3D printing can really save the day, literally save the day. I'm so glad you could join us.
Well, thank you again for having me. And I would love to stay because everybody here seems so fascinating and way smarter than me. Unfortunately, I do have to go to another event, but thank you so much.
Well, thank you for stopping in. And I keep trying to make it to the women in aviation meetings, and I've made, I think, one, but I'll get there.
That's okay. We'll see you when we see you.
Bye.
Thanks.
So Jed and Alec, do you want to go next?
Yeah, do you want me to share my screen, Sarah?
Sure. Do I have to do anything, or I don't think I have to do anything. I think all you have to do is down the bottom. It says mic, camera, screen, and just click on screen, and you should be able to share. Because technology is fabulous.
Always
for
work.
everyone else, you can change your view everyone up top to view who's talking. And I think you should be able to see just his screen.
Yeah, I'm not seeing it. I'm seeing Brandon.
He has to start talking first.
Okay, so is this working?
Yes, it is.
Great. So here's our project called Yo-Yo's Wheels. It's for
I'm sorry to interrupt.
a bunny named Yo-Yo who's getting both legs amputated. So far, she's had one leg amputated, and then now waiting for a surgery for the second. Jed can tell a little bit about how it started here with Liz reaching out to us.
Yeah, so she sent us it was basically a doodle on a napkin, and it had a few design requirements. I can't see the slides for Alec, but I think one of them was a low center of gravity. It needed some off-road capability, not really off-road, but like carpets. I can't remember what the third one is, but I think it's important to illustrate that like you need to get at least some kind of idea from a client of what they want, so you're not just guessing from thin air. So even just a doodle on a napkin is better than nothing. Mr.
Yeah.
Alec.
And I guess I'll add to that, and maybe the slide will pop up. But another couple things was that she wanted it to be detachable from the base and adjustable, and then for a jacket, like something that would snugly hold the rabbit or the bunny snug. So the next step for us was speaking with a man named Adam from Dive Design in New Jersey, and they've been able to make quite a few different animal wheelchairs and prosthetics. And this was, if you can see it on the screen, an example that they made for kind of a smaller dog. The pink part is printed from TPU, so it's nice, flexible, and then those straps at the top will hold it against the animal. And
I'm not seeing your slides. Is anybody else seeing them?
No, I was going to ask if you were sharing something.
Oh gosh.
One time. So when you go down to the bottom and it says mic, camera, screen, does your screen? So you have to move your mouse.
I can see your screen now.
Yeah.
Yep.
Oh, there it goes. There it goes.
Is this working? Okay.
Yeah.
Yep. There it is.
Sorry, I'll jog back a little bit.
Yeah,
So
yeah,
y'all can see the photos again.
yeah.
Um,
There's Liz's sketch.
yeah, so this is her kind of nice way to put her idea out on the paper. And you know, she has no experience with 3D printing or really much as far as design or anything, but she had this idea, and it did give us a lot of direction for where we'd go next.
Yeah, and on as Alec was saying, she didn't have. I mean, she thought she in her head she was. I think she was picturing like a wooden circle with caster wheels on the bottom, so that the rabbit could just scoot around in 360 degrees. But I don't think she knew the capabilities of a 3D printer, so we sort of upgraded her design.
Yeah, and then so here's Adam's example that I was talking about. So hopefully that makes a little more sense now that you can see it. And what's really interesting is the pink part is made from a generative design script that they use for all their different wheelchair jacket membrane components, so that we just have to 3D scan the rabbit and get the dimensions right, and then they'll be able to run it through their software to make a similar jacket that they know works really well. They've done it with like large pigs and then a few different animals, mostly dogs. But so we had to get a little creative as far as what we're going to do to make this work for a bunny. Here it's kind of showing our process going back and forth from the whiteboard, using Fusion 360, where we kind of just spread it between us, and we were responsible for different components, and it was a great software to use.
Can I ask a question?
Yeah, definitely.
On the previous slide, you noted that you had used TPU and also carbon reinforced nylon. So is the pink the TPU and the rest of it is carbon reinforced nylon?
Correct. Yeah. And this is the example that Dive Design did for a smaller dog. So it's good. Pretty different design because, you know, the front legs of a dog, it can still push itself around, as opposed to removing the back legs of a rabbit. You know, it's but it was a really cool example, and it kind of gave us a good direction from their experience.
Okay, thank you.
Yeah. So this is kind of what ended up being our first prototype here, to get this low center of gravity that Liz wanted for the rabbit. And on the far right picture, you can somewhat see the mechanism where she can adjust where the cradle is holding the rabbit. It can slide back and forth, and it's removable too with that pin. So to move forward from there, Jed can talk a little bit about the wheels.
Yeah, so we're TPU is, if you're unfamiliar with the material, it's slightly flexible. It depends on the brand how flexible, but the stuff we have is I'd say like medium. So I designed a cylinder with tread, but we didn't actually model this pattern in the top picture that you see inside the infill. So we printed it without top or bottom layers, and this let it, so it's in a flexible filament. It can deform a little bit, and like it acts like rubber on a tire. So this was a small test piece. We have the actual one is going to be I think like that big maybe. I can't remember the exact size. But like saving steps where we can.
And what type of technology are you is your printer using?
We were just licensing it. It's just a Core XY FDM regular. You can buy them off the shelf.
Thank you.
Yeah, yeah, it's
Yeah.
I'm sorry, Alec.
No, go ahead. Sorry.
Oh, I was just we just sliced it in Cura and selected gyroid and just cut off the top and bottom layers. It's not a huge, it's not super difficult.
Yeah, so
I have a quick question.
go ahead.
Has the bunny figured out, does the bunny still try to hop, or has it gotten used to the, I remember in
Yeah,
Sarah's email, she's put something about
so as the
I'm
bunny
looking at the
right now,
wheels, imagining the poor bunny, like, you should have put some springs in there too.
yeah. The bunny right now has one of the legs removed and it's waiting on the surgery for the other. So it'll be nice once it's had the surgery and it's going to be a little bit lighter and be able to pull this cart with its front legs. So it's trying to have it have like as little resistance as possible, but then still have, you know, the cushion of the wheels and everything. And in this picture, you can see this is kind of the same idea that we're using for the wheels. Is this gyroid infill with this is made out of the TPU, so it just squishes, but then it will return back to its regular shape. And we were able to just get a few different components from McMaster Carr through Fusion that we can just kind of input into our design, so we know everything fits. And they were really quick to order. And we couldn't use the same axle design as Adam, so we had to get these little scooter axles. But besides that, we just tried to keep it as simple as possible for Yo-Yo. And so that's the end of our presentation, and we're keeping people up to date through the website as far as Yo-Yo's status. And once she's finished with surgery and rolling around on the cart, we'll get some videos and stuff on there too. And we're running a little campaign to help pay for the surgery, for that second surgery. So that's all on the website. And I printed out like just a little version of the cart here. So, yeah, can everyone see my camera screen?
I can see you again.
Cool. Yeah. So here's the cart itself without the TPU sleeve, and there's the little locking pin through it, and then.
And were you guys using Cura for this program to make this?
Mm-hmm.
Okay.
Yeah, so we were using Cura to slice the models to have them ready to be 3D printed, and then we were using Fusion 360 for the modeling. And yeah, that's I know we went a little over on time, so sorry about that.
Well, we had a strange one there at a time because we had questions during the presentation, which was okay, you know, it was fine. But it is a really cute project. And so the New Mexico House Rabbit Society came to us because I had adopted a 3-legged bunny who doesn't need a prosthetic. She can outrun me when she's done bad deeds. And so she can get around. She's a little monster bunny. But poor Yo-Yo, of course, with 2 legs paralyzed, it's a lot harder. And what I was saying, Deb, in my email is that you know, the mechanism for a dog is different for a rabbit because their anatomy is different, because their anatomy is set up for hopping. It will be really interesting to see what happens when she gets the prosthetic. So the beauty of 3D printing, of course, as you all know, is that you can iterate the design so that it works, you know, after you have failed a number of times. You figure out real quickly what needs to be done. And she's having her second surgery. This is really kind of yucky. I don't write about it, but she chews on the dead legs, and that's why they're amputating. And they were afraid of her getting infection. But she's such a little sweetheart. And my little bunnies, well, I have a normal bunny who is my bunny's husband, but Julie, my three-legged bunny, is just such an interesting animal, and plays catch with me, and is so in tune with what goes on, and it's just I don't know what I would have done through coronavirus without her. And you know, she looks at me and she can tell when, you know, things aren't right, and she's just so communicative, even though bunnies don't speak. And Indy was saying, could we make them stomp? Stomping is a bad thing in our house. When the bunnies are stomping, it's like during the thunderstorm, or it means they're mad at me. So I think a bunny without stomping in the house, in the wild, they stomp in order to warn the other bunnies of danger. And so they're often trying to warn me of danger, but they're usually trying to tell me they're mad at me. And it's hilarious because you'll get them stomping, you know, and it's like, so then I just stomp back. But that would be perhaps a really great future project, indeed, that we could work on. Is how do you get a prosthetic stomper?
I've had a bunny named Thumper when I was young, and he did not like this rabbit did not like anyone in the house but me. My dad could not stand this rabbit. My mom couldn't stand this rabbit. He was a good rabbit though, and like I was able to deal with him. But I always remembered whenever my dad like went to pick him up or tried to pet him, he'd move away and just stomp at him and then hop over to me. He was a really good pet. My mom unfortunately left the screen door open one day, and he got out, and I never found him. So it broke my heart. I never got another bunny after that. I only saw my friends. I never ever got another one.
Yeah, I don't know what I mean, I got Julie, she was 1, and they typically live to 10 or 12 or 14. So, you know, but yeah, I don't know what I'd do without her. I mean, I think I knew her in a past life. You know, we have that kind of bonding. And it's funny when you talk to other bunny mothers, you know, so Inti and I could go on it forever, but we won't. There's a funny cartoon among the bunny people that says, what do you mean you don't want to see the 500 pictures of my rabbit? You know, and that's my cell phone. It's the 500 pictures of my rabbit. So I'm really grateful to Alex and to Chad for working on this, because it's a project that's really dear to my heart, and it's good. And I think if we can solve a problem for the bunnies that do get paralysis, you know, it might really help other rabbits besides Yo-Yo. I'd like to say a word while we're here about Jed and Alex's program. So we have a U.S. Department of Labor registered apprenticeship. And so how many of you know what a registered apprenticeship is? So, well, Jed does. So a registered apprenticeship is through the U.S. Department of Labor or through your state Department of Labor. And it is a really organized and structured pathway to a job. And registered apprenticeships have traditionally been in skills like carpentry. I visited the oh, the Carpenters Union, I think they're called, has this amazing training facility in Las Vegas. And I mean, they do things like underwater welding. I mean, it's totally out of control, high-tech stuff. But you get a very, very solid training in a particular skill. And during the apprenticeship, you get to take courses for free. So traditionally, if you're not like the Carpenters Union that has your own training center, you would go to a college or a community college and the employer pays for it. And the apprentices earn 2/3 of a starting salary. So you're getting paid 2/3 of an entry-level salary in order to learn your trade while you're getting free education. And it is a wonderful government program. I was fortunate enough to get to meet the head of apprenticeships for IBM. And Ginny Rometty, the former CEO of IBM, has a very, very robust program that they put in place when she was CEO for apprentices in IT. And so our program uses the digital badges that we developed with America Makes, and our apprenticeship is for an additive manufacturing technician. And my feeling is that these apprenticeships are really amazing ways for people to get new careers, and particularly with COVID, where people were displaced by COVID, and here you had a really nice job, you know, in hospitality, but suddenly it's gone. And I think it's a wonderful opportunity that we've been able to work with IBM on. And our apprentice sponsor is Youngstown State University in Ohio, and which is where America Makes, the 3D printing National Manufacturing Institute, is located. So it's very incestuous, but it has built this ecosystem. And if we can start to get more people into these kinds of programs that are supporting them without getting into and all of you know that I get on this bandwagon about, you know, we don't need 4 years of college debt. We need to have something we love doing and that is engaging and fun and allows us to support our families. And I think apprenticeships are a wonderful, wonderful pathway. There's a lot of talk in the Biden administration. I wrote a policy paper that a group out of the Obama White House asked me to send to them. And many of the states, California, New York, are talking about increasing funding for apprenticeships. But I fear that they're going to want apprenticeships for those old jobs, and we want them for new collar jobs. We want them for the jobs of the future. We want to build 3D printers. You know, we don't want to work in coal mines. And so I think we're really fortunate in New Mexico that we have a really innovative program. And I tried for 9 months to make it happen with the state. And thank God I met IBM, and we have a national program. And so if any of you are interested in learning more about 3D printing technician apprenticeships, I can put you in touch with IBM, or if you're wanting to start an apprenticeship program, or with Youngstown State. And the woman at Youngstown State used to be at IBM. Everybody's interconnected. Or if you're interested in looking at our program, we'll probably hire 2 or 3 more apprentices in the summer. So I'm really passionate about this because I really think it's important for the health of our economy and our country, and will allow our country to really prosper. So Jed and Alec are great examples of guys who came to work with us in our apprenticeship program. And I chose them specifically because our lab manager was leaving and I wanted people who, you know, had to step up. They both had some experience. They both had their own 3D printers. They both knew CAD. So they weren't starting from zero, but they've done such a great job, and they only started March 1st. And I'm really, really proud of our program, and any way that we can help all of you or help the manufacturers in New Mexico or the other companies, you know, I'd really love to see how we can not just have it our little program in my little lab in Santa Fe, but see how we can expand that through the state. So anyway, that's my pitch. And last but not least, Brandon. So do you have slides?
I do. I threw together something real quick. So I'll share my screen.
If you move your cursor down the bottom, you'll see my camera screen.
I got it.
Just go.
So can you see that? I'm going to do present now.
Yep, there you go.
Okay, cool. All right, yeah, so here's my quick thing that I threw together for rapid prototyping. So a little bit about me. I'm an Albuquerque native, and I've been taking things apart for a really long time. And so I went to study engineering, and I got my BS in mechanical engineering with a minor in aerospace at New Mexico State. I was introduced to 3D printing when I was probably like 14, 15. My mom and my stepdad bought a printer, a MakerBot Replicator 2. And the reason was because we had some pinball games and my stepdad wanted to make some accessories for them. So we bought a $3,000 printer to do that. And me and my brothers, of course, so we printed all manner of inappropriate or whatever stuff that we could back in the day. And 3D printing, desktop 3D printing was just getting going then. And so it was like a new front. There was no Thingiverse, there was no anything. It was just whatever you could draw and then find online in the corners of the internet. But I guess I'll start with like the typical design cycle for prototyping, where you do concept proofing, detailed design, testing, you get feedback from the testing, and then you refine the prototype. But typically, the prototyping takes a lot of time, both lead time for manufacturing, tooling and stuff, and it's also very expensive in the traditional sense. So with traditional manufacturing, you're looking at tens to hundreds of thousands of dollars, depending on what manufacturing method you're using. So say you're making like a tank or something like for windshield wiper fluid, and you wanted to prototype it and pressure test it and all of that. To do like a mold for that, you're looking at, huge lead time and big money to do it. And not only that, you also have the design for the actual part that you're doing, and on top of that, you have the design for the tooling. So there's all those other considerations and specialists that you have to have on hand. And so with additive, obviously reduce that down. You make it to $1 sign instead of 3, and tens to thousands typically, depending on the product. We're talking polymers here. Obviously, with metals, it can be different, but yeah. So the real value add there with additive is reducing the time in prototyping. And so since you have that time freed up and you have resources freed up, you can do a lot more testing, and you can explore the design space with greater freedom than you would be able to do with traditional manufacturing. So before I came to Roadrunner, I worked for my family business, which is with pinball, because the small pinball hobby that my parents started became a massive business here. Well, it's not massive, it's like 6 people, but they run it really lean. But basically, we designed accessories and like cosmetic stuff for pinball games. So basically stuff that the manufacturers didn't do. Just wasn't in the budget, or they couldn't, it wasn't feasible, whatever, we do it. So we're always trying to beat competitors to the market because we kind of carved out this mod area of the pinball market, and then new competitors came in after we had established ourselves, and they started using additive like we had. So it became like a new game comes in like fresh from the manufacturing line, and we usually get it early through a deal, and then it's like we have 2 weeks to get products out before the competition do. So it's like basically a case study in rapid prototyping. And typically I would start, and the other designers, we would start working on stuff before we even received the game, whether it's just concepts or if we had pictures with like rough dimensions that we could start. But we also use additive as our main manufacturing source. And it's really great for high mix, low volume. So we have like 600 products, and we're doing on-demand manufacturing. So like orders come in, we don't keep stock. It's just like made to order. And so 3D printing is really good for that because we just have a farm, and it's like today we're making this and that. You can't really do that with other manufacturing methods in a cost-effective way. So, and also enables us to do high complexity and again, store everything digitally. So here's just some quick examples. So there's, this was for Led Zeppelin that came out just before I left and started at Roadrunner. This was for the Led Zeppelin, and so you can see up top the one that was in the game. It was my first iteration, and then the second iteration, and then there it is in game, ready to be sold. And then here's another, example of like exploring different, like a design space. You can see that there's actually the Zeppelin over there on the left, but over here on the right, it's very empty. So we wanted to do something there. And I came up with, let's do Big Ben. And so I drew Big Ben and threw it in there and lit it up. And then we were thinking, so maybe we do something else. We add something in. So I added the Parliament building, and then the final product is getting it in there. So this is something that you can do. I mean, prototyping like this, you can do it in a traditional sense, but with additive, it's really just painless because I can just do this. I can explore the design space however I want without really the constraint of dollars and time that there is with traditional. But I stopped making toys and I moved to Roadrunner / Westwind. And we have industrial scale stuff here. We specialize, our bread and butter is HP's MJF powder bed technology. Huge printers, no supports, very cool stuff. And then we also have some EnvisionTech SLA printers, and then the very special Desktop Metal Studio, which is an FDM metal printer, which is very cool. But here I basically am doing the same things, doing prototyping for clients, but we have some industrial clients as well. So I'll show an example of something that I'm working on currently. So we've got this, basically it's an end of arm tool. It's a mounting bracket. And so for those of you that don't know what an end of arm tool is, it basically goes on the end of a robot. And here's, I don't know if you guys can see me or can see this.
Yep.
But this is it. And so this goes on the end of like a Johnson & Johnson, robot in the factory, and it moves stuff around and whatever. But it's very heavy. It's unnecessarily heavy. It's made out of aluminum, which under the loading, which is just gravity and then the torque applied from these, it's really not necessary for it to be made out of aluminum. It's over-engineered, and through my simulation, I determined that it's basically 25 times safer than it needs to be. So We basically, this is the first iteration prototype
Wow.
that's extremely light. It's 90% lighter to be printed in PA12 nylon. The only problem here is that it's 50 times more displacement. So under the load, it's going to move 50 times more than the other one, which even though the aluminum one doesn't move very much, it's probably going to, I think it moves on the order of like a couple millimeters. And then this one it's 2 times away from breaking. So basically we could double the load on this before it would break, which is kind of like typical in engineering to see a factor of safety of 2, but we want to not have as much displacement. So this is the second iteration that I've done, which is a little bit thicker, but it's still 70% lighter than the aluminum, and it has 5 times the displacement, and it's 5 times away from breaking, basically. So this is something, again, we can do these prototypes very quickly, but we also have the ability to make them quickly. There's no need for me to set this in a 5-axis mill and have it run for 2 months just to get one part, and cost thousands and thousands and thousands of dollars. Here, this will cost, tens to hundreds to the client, and it's, we can really truly do some amazing stuff with additives. So yeah, I think that's all I have. So
one question real quick. Oh, sorry.
Yeah.
So whoever said it first.
No, I was saying, any questions?
The second iteration that you were sharing, what was the percentage of movement after you improved the design?
So it will still displace 5 times more than the original, but the original is displacing 0.1 millimeter, and this one is only going to displace 0.5 millimeters. So it's still very, very, in my opinion, it's negligible because the alignment, the thing is so big that 0.5 millimeter is, no one is going to notice it.
Yeah.
So, well, we'll see though.
Than what you had. So.
To be continued.
Yeah, to be continued. We'll see where it's actually printing. It's printing out right now. We just threw it in the printer today, so I added it on there, and we're gonna see how it does. So maybe if we meet again, then I'll be able to show it up, and we'll plate it in chrome and put spinning rims and everything.
We will meet again. Well,
Yeah.
Brent, for me, I think because I've done so much prototyping for customers, particularly in the medical device field, is the power of digital is that a design never works the first time. It may not work the 10th time. And what was it that Edison said? I didn't fail. I just tried 10,000 things that didn't work. And that's what invention is about. Invention is about you keep trying until you get it right. And I apply that not just in engineering, I apply it in marketing and everything else we do, but it's really expensive in engineering. And with digital fabrications, so whether it is laser machining but particularly additive, if a design doesn't work, you don't have to have spent $1 jillion on a mold. You go back in, and as the additive people say, complexity is free, and you can keep iterating, and you do those iterations in CAD. So you're not making 100 moles, or in Edison's case, 10,000 moles, right? Edison just kept iterating. And I think that's the power of it, is that you can iterate a design until you get it so close to what the biggest part of your market share needs, that when you go to market, you are going to be pretty sure that you're going to be able to own the market. Your you're going to be right there. And that's to me, that's the power of it. That you come out with a product, because for me it's about products. You come out with a product that when you get to market is right there. And it's because you iterated the design a jillion times and it didn't cost very much.
Yeah. You can also, one of the things that the way that I look at it is, traditionally you have to employ somebody that's going to try to think through how everything will fail in a traditional manufacturing sense. Like when it comes out, when you have the final product, you have to think through how it's going to fail. So you have to employ somebody to do that constantly. Whereas with AM, you can just try it. You know, it's like you said, complexity is free and things are very cheap to make with AM. So you still need to do a little bit of that thinking, obviously, but it's not as intensive and time consuming as it is in traditional.
So as a lot of you know, I come from laser machining. So although I love additive, I try to be realistic about its place in the ecosystem. And the same is true for a lot of digital fabrication. And but that's exactly right. Whether I mean, if I'm laser micromachining something, it's the same. This exactly what you're describing, where I'm able to change my design in CAD. I didn't have to make a mold. Yeah, and so I agree with you. But to be very clear, that isn't exclusive to additive. Some subtractive, particularly the digital manufacturing capabilities. Some, you know, not a Bridgeport mill, but other kinds of capabilities will also exhibit that. And that's the power of digital manufacturing. And so in my world, I combine all of those tools, so additive and laser machining and, you know, all kinds of technologies in order to work in a digital virtual space, and then I make stuff. Does that make sense?
Does.
Yep.
I mean, I love 3D printing, but you know, given a choice, I'd laser micromachine anytime. So.
Bill, what did you say? I missed what you said.
Well, because you know, I come from a laser space that is extremely robust and is very repeatable and predictable. And so I feel really comfortable in my laser world, and I love 3D printing. And I built lasers for Chuck Hall in 1986 when he was inventing stereolithography. So I've been in the space a long time, but it's still, you know, it's still finding its legs. And I think we have to think broadly about digital manufacturing. And in my mind, I always choose the right tool for the job, and sometimes it's additive, and sometimes it's something else. And for me, it's about the customer. And if I can do it faster, cheaper, you know, better with additive, that's how I go. So my world view is about manufacturing and what is the right tool for the job. And what I would like to see us do is help people go to additive when it's the right choice. Because if it's not the right choice, you're going to beat your head against the wall constantly. But if it's the right choice, you're just going to nail that application. And that's what our role is to really help our customers make the best products and make money for their investors and solve world problems. And for me, I don't care what the tool is. So,
Agreed.
Yeah.
but prototyping is where additive shines.
I got a question for Brandon. If you've used any of like generative design for the pinball machines at all, if you've been able to do that.
No, because most of the stuff that I designed for those was cosmetic and none of it is load bearing. It wasn't really necessary, and I didn't have access to the tools, but now, I mean, now that I do, I kind of wish, now how can we, you know, put lattice structures on the pinball games, but yeah, no. The closest thing we did is we did acquire an SLS printer right as I was leaving, and we did some minor work with like packing algorithms and bin packing and stuff like that, but nothing crazy.
So which generative programs do you use, Brandon?
Right now I have a trial of in topology, but we're looking at a seat and we've talked to them about it. And so they've offered us their small business license. And I think we're going to get that here soon. So
and I have not looked at it. I had a quick demo at a trade show, but have you looked at the hold on, I can't think of his name. Parameters?
no, is that what was his name? Or
the company is Parameters.
Parameters. No, I haven't heard of them.
I'll send you a link.
Yeah, that would be nice.
It's one of the companies that Avi Reichenthal invested in and is helping foster in his little ecosystem out in Ventura, California. And Avi, as you know, was the former CEO of 3D Systems. And I had a quick demo, but I haven't used the program.
Yeah, there's a few different solutions in there. There's add-ons to popular CAD softwares like SolidWorks and Fusion, and some. I know that Fusion has integrated some of what previously were just add-ons into actual or bought, you know, the ability to run it.
Wasn't that called? Let's see. That was called. Oh shoot! I wrote about them. No, I can't see it.
And I apologize. I'm going to have to drop. So it was good to see you guys.
Thank you, Susan.
Susan.
Brandon, awesome job. And I know he's got a printer to start, so be kind to him. Don't talk to him too long.
Yeah.
We'll talk about having an in-person event.
We actually, Mary and Deborah and I talked about August as a possibility at Westwind. So we can chat about that.
I have the MIT International Annual Meeting, so it might be hard to do it in August, but maybe September.
Yeah, we can certainly talk about it. So we did looked at the space and we have a spot to do it. So you can all meet Brandon live.
Yes, and we can all bring our samples.
Yeah.
Susan.
Okay. Thanks again. Have a good evening, everyone.
Well, isn't it amazing? An hour and a half flashes by when you're having fun. Any other questions for the speakers?
I just wanted to thank you guys. Like, this is my first course coming here, and it's really nice to see that there's people out there that are interested in this field.
I've been trying for upwards of a year just to find any information on this. So this is the first most helpful meeting. So thank you guys.
Thanks. So I belong to a totally crazy group, an international group that meets every other Thursday called 3D Drunk, and we mostly drink and talk about 3D printing. So you can only imagine what that's like. But you can drink other things besides alcohol. I mean, you can drink water, which sometimes I do. But they're really fascinating people. And there's a woman named Alex Kingsbury who's doing a PhD in Australia, and it's just a really fun group. And Indy, I'll invite you to 3D Drunk for sure, because I know you would love them. And it's just this group of really innovative, and that's how we know Adam, who helped us with, which I probably should not admit, but how I met Adam was in the 3D Drunk group, and who helped us with our yo-yo project. And they're creative fun. So if anybody wants to, get an invitation to our group, and they're out of control. I mean, they're really successful, and there are CEOs and startup people, and there's a guy at X1 who is a fellow who never graduated from college and has been there 20 years, and it's just we have a really great time and talk about technology and applications and kind of what's happening in the world. So if anybody would like to join. So Indy, I'm so glad you found us, and I will definitely introduce you to my other groups.
I'll try to keep myself under control. I'm like a one-shot girl and then I'm gone. So unfortunately I don't weigh very much. I have to watch that.
Well, I hopefully see you all next month. Mary and I will work on next month, and I'm hoping, Mary, that we can kind of get a consistent schedule going so that it's easier for MK and I to get people to speak. So we have a little more lead time.
How about the 16th of June? That's the Wednesday. That's the Wednesday following this meeting.
Wednesdays are good for me. We could, see how Wednesdays go. I have nothing on the 16th of June, so I can do that.
Perfect.
Why don't we see how Wednesdays go? I think 5 is better than earlier. Would most of the group do that? I think if you're at 4, it's, people are still, I mean, I'm going to go back to work after this, but 5 on the 16th? Yes, no, maybe. Let's try it, and we'll figure out a good day and time, and I'll send the information for August, which is the week of the 9th, and that will be a big event and in person in Santa Fe. So and then we would just have July. Okay.
Sarah, may I suggest something? I wonder if we could, would that be all right?
Mm-hmm. Yeah.
I wonder if we can just put it out there that if anybody knows anyone in your industry, maybe you're not speaking today, but you know someone in any kind of industry, whether it's the food industry, cosmetic industry, aeronautics, automobile, or auto industry, please reach out. Here's the place where we can connect and meet, and then bring you guys back, or people that you know as Ignite speakers. So please share those names and numbers with us here as well, so we can broaden the community.
That would be great. And I'd really like to see more people who know nothing about 3D printing. I'd like for us to be an education group. you know, where we reach out to, you know, the people in the factories or the people at Walmart or the guys at Amazon warehouses and see how we can expand beyond our own little group. So this has been way fun. And thank you all to the speakers. Brandon, so great to hear about your work. And we're going to make it June 16th at 5 p.m. Yay! I love Mary. I love solid planning.
That's how Mary is. She's amazing. Okay, Alex, we want to see your puppy.
Yes, please. What's his name or her name?
You need light.
It's Django.
Oh,
Django or just Django?
Oh,
Django.
oh, what a cutie. How old is he?
He's like 9 weeks.
oh,
He's a baby.
Yeah.
is he a Labradoodle?
Yeah, he's a Labradoodle. Getting big. He's like bigger every day.
Yeah, he's gonna be giant. My sister has one. She just got him. He's just about 2 or 3 months. He's giant.
Oh,
He's
really?
so cute.
Yeah.
Oh, what a cutie.
He's so hard to take pictures of. Nothing shows up.
Julie is like that. Julie is all black and has white paws. And I have way more pictures of her husband, Grayson, because gray, and I can get good pictures of him. And poor, I mean, yeah, they absorb the light. Yeah, it's hard.
He's got a little white. He's got like a little white star, but it's hard to see.
Oh. Well, I'm glad you have a bunny, a puppy, not a bunny. So thanks for coming. And, you know, let's just keep encouraging each other and seeing what we can do. And let's definitely, for New Mexico, increase the opportunities that are here.
Sounds good to me. Have a great night, guys. Thank you.
Sounds great. Thanks so much, Sarah.
So fun to meet you all. Soon in person. Thanks, Chad and Alex.
Should we stay on or shall we talk by phone or say goodnight?